Doctors recommend that teenagers get 8 to 10 hours of sleep every night, but many are sleeping far less than that, and nearly 1 in 4 also suffers from insomnia.
In today's modern age, sleep disorders have become a prevalent and concerning issue affecting people of all ages. As a result of our increasingly connectivity of digital lifestyle, work demands, sleep problems have become more prevalent, and conditions such as insomnia, sleep apnea, and circadian rhythm disorders are now more common than ever. Factors like excessive screen time, irregular sleep schedules, and high stress levels contribute to these sleep disturbances. It even impacts our mental health. Addressing these challenges and promoting healthier lifestyles has become an essential aspect of maintaining a balanced and thriving life in the era that we live in. Now, let's analyze some real world data and look into what actually is the problem behind such sleep disorders. We'll also predict the chances of a person who's likely to develop a sleep disorder. For this analysis, we'll be using Jupyter Notebook and few libraries like Pandas, NumPy, Seaborn, Matplotlib, and Plotly.express. Now let's look into what actually the dataset looks like. So this is the dataset that we'll be analyzing. It's actually a CSV file as you can see here, which means comma separated values. I'll show you what that actually means in a moment. So before that, let's go through the dataset. So in this dataset, we can see that the main attributes are present over here. Here we have person ID, gender, age, their occupation, their sleep duration, their quality of sleep, their physical activity. Here the physical activity is out of 100. It has their stress levels, body mass index, blood pressures, heart rate, their daily steps, and the final outcome, which is the sleep disorder. So now let's go into Jupyter Notebook, which is in my VS Code, and start analyzing and visualizing the data. This is our workspace for today. So before exploring this, let's look at how a CSV file looks like. So as you can see, a CSV file is not separated by rows or columns, but actually by commas. The delimiter over here is a comma, so that's why it's called a comma separated value. Okay, let's get back into our workspace. So the first thing that we have done over here is imported libraries. Obviously, before importing them, you have to pip install them. I've already done it. So now I've imported NumPy with an alias as NP, Pandas as an alias with an alias PD. Alias are actually like very important. So because we need not write NumPy all the time, we can just write NP, and that's the case with all the other libraries. So first step over here is importing, and then I've read the CSV file. So here with pandas there comes a method called read CSV. There's a lot of other options. For example, let's say pd.read. You can see there's a lot of options. See, there's CSV, Excel, HTML, JSON, and a lot of things. Pickles. So now for we have a CSV file. So let's go with CSV. Our Excel file name is sleep.csv, so that we are taking the same. It's in the same folder, so no parts are included. Now, let's start exploring the data. So first step over here is data.info. Data.info is useful for quickly understanding the composition of our data. So let's look at it. So we can see here data.info gives us all the attributes, that is columns, and also it gives us all how many null values are there or not. And also it gives us the data type of each attribute, which is very handy because we know that the IDs, person IDs of type int, gender is of type object. So it's very handy to get an overall idea of how our data looks like. And the next step we have done over here is data.describe. Data.describe gives us like the basic statistical measures of all the attributes in our data. So here we can see that the count is given, the mean, standard deviation, min, max. This is for just analyzing, just for getting an overall idea of how our data set is. And the next thing that we have done is data.head. Data.head is nothing but it returns the first n rows of the dataset, and the n is given in the parameter of head. Here we have given the n as the parameter as 5, so it returns the first 5 rows. So let's say we enter 100 over here, so we don't get all the 100 rows, we get the first five and the last five so that we can analyze them in the same place. So let's run this. As you can see, we got the first five rows over here and the last five rows. This becomes very handy when we're exploring and analyzing. So now let's go to the next task. Here, the first very important task of data exploration and analysis is to clean the data. So in our data, so this is like a very small data set, but in real life we get data set which has millions or 10 thousands of data. So in that case, it the data is not always clean. So what happens is we are supposed to clean the data. So actually, first let's understand what an unclean data is. Unclean data is nothing but it contains NaN values. NaN is nothing but not a number. For data analysis, we need the values to be in a number format. So in case if there is no value present in the rows of attributes, we should uh, we should actually remove those columns. That's the first step, and it's called cleaning the data set. Now let's clean our data set. First, we are on our analysis over here, we came to know that sleep disorder contains some null values. It contains some NaN values when I took it from the internet. So what I've done is I've taken the sleep disorder attribute from our data. Data is nothing but the data that we got from our CSV file. Where is it? Huh. And I've removed all the NaN values. So fill Na is nothing but, as you can see, if you keep it here, it fills all the null values with the value you have given in the parameter. I've given here that I want to fill all the null values with the value called none, value called none. So what it does is it replaces all the null values with none, and in place means it actually replaces all the values in the real data set, which is our CSV file. Now we are just printing the disorder value counts to see how many um, unique values are present. Let's see. There are three categories: people with no disorders, people with sleep apnea, and people with insomnia. So the majority of the person that we have discovered that we are exploring has no sleep disease, which is actually a very good sign. And then almost 50% and there's an equal composition of people between sleep apnea and insomnia. So we are going to analyze what actually is the cause of these. Now, what I've done, so the next step that I've done over here is I've used px.py. Px is nothing but plotly.express library. I've taken plotly.express with an alias called px. So it's very handy to use it here. No need to write plotly.express every time. So I've used the py function of plotly.express library, which takes in the data and the names and title. The title comes here, it's self-explanatory, and the name is over here. If you hover on the data pie chart, you get sleep disorder over here, sleep disorder over here. This is the name. Now, after I do this, I get this beautiful pie chart, which is actually very easy for visualization. Now let's see. As we saw over here, this is in wording format. Now this is in visualization format, which makes things very easier. We can see here that around 60% of people have no sleeping disorder and around 40% of them are suffering from disorders. Let's analyze what causes those disorder. Start analyzing each and every attributes in depth. Now we'll take occupation as a parameter under consideration, and we have done value counts. Value counts is nothing but we get all the unique values in those columns with their counts. So here we get all the unique values as nurse, doctors, engineers, sales managers, and their counts. Here we can see that majority of the population under consideration are nurse, and then doctors, and then engineers, and it goes on. It decreases from top to bottom. Thing we have done is sns.conplot. sns.conplot is nothing but, so what is SNS? SNS is nothing but an alias that we have given for Seaborn library. We have taken the conplot function from Seaborn library and given the data as our data set and the y-axis data as the occupation. U is nothing but, as you can see in this visualization, we get a more defined like a legend, so that's called the new. So when we plot this count plot graph, we get this visualization. It's nothing but the same as this. Here we can see that software engineers and managers are not likely not suffering from any disease, and sleep apnea is majorly suffered by nurses. And doctors are not suffering, and majority of the doctors are not suffering from any sleep disease, which is understandable because they're doctors, they know how to take care of themselves. And scientists have no insomnia, accountants have no sleep apnea. So these are all the data or understanding that we get from this visualization. Now let's get into the age category of each people in an occupation. So for we can get the average age of each population in an occupation by this method. We group the occupation with their respective ages and we get their mean. Mean is nothing but the average age, and then we reset index. Reset index is nothing but we get the values plotted from 0 to the respective number. As you can see here, this generated this tabulation. It starts from 0 to 10. That's what reset index does. And we get occupation and age. That's where we grouped it. We get the mean age of accountant is 39. And let's look at nurse. The mean age of nurse is 51. So it says why most of the nurse are suffering from a sleep disease. Okay. The next thing is we have done a tabulation format. Now let's try visualizing it in a diagrammatic manner. For that we have done for that we have plotted a bar graph using a Seaborn library, where we are given the x-axis as age and y-axis as occupation, and the data as average age by occupation. Let's look at it. Here we can see that this is like the same thing that we saw here, but in a more beautiful manner, which makes us to understand it even further. Here we can see that the mean age of nurses are around 50 years, which is around 50 years. And sales representatives are the most youngest people over in this surrounding, around 30. Let's look at average sleep duration. We are doing the same thing. We are grouping the occupation by sleep duration. We're getting the mean and resetting the index. Here I've not like printed average sleep duration. That's why I'm not getting a tabulation format. Let's analyze using diagrammatic format. For that, I'm using the same bar plot function from Seaborn. I've given x-axis as sleep duration and y-axis as occupation, and the data as average sleep duration, which we got from above. So now here we can see that let's look at nurse first because they're the ones suffering from sleep disorders. Nurses are getting an average sleep of 7 hours, and engineers are getting an average sleep duration of 8 hours. The minimum is ge- getting let's take so the minimum sleep duration is by sales representatives and scientists. So these are not bad numbers. So let's look at another analysis. We observe that nurses in our dataset mostly have sleep apnea, baby, because nurses are mostly older than 50 years old. Yeah, we analyzed that, right? And teachers mostly have insomnia, possibly due to stress or lack of sleep duration. This is our interpretation. Now let's look at another analysis. Now we are looking at genders. Now we are looking over genders. We have two genders which are male and female, and now we are doing the same value count. It gives us the unique values and their counts. So getting that, we see that there are over 189 males and 185 females. So the proportion is almost equal, so no outliers over here. And then the next thing is, with the help of Panda library, we are doing cross tabulation. Cross tabulation is nothing but we get a table like format where the index is sleep disorder. You can see index is sleep disorder. We have insomnia, no disease, sleep apnea. We get this, and column is gender. We get two columns over here, which is based on gender, where female and male are unique values. So we print that and we get this. Analyzing this, we see that 137 out. 137 males are not suffering, 82 are suffering from a disease, 82 are not suffering. So insomnia, male are suffering more from insomnia and females are suffering more from apnea. So it mostly lies towards female. Female are mostly suffering from a sleep disorder. Next thing is, let's visualize it in a beautiful manner. For that, we are using Seaborn library, and the function is count plot. We did the same thing above. We're taking count plot and data as the data of data set, and the x-axis as gender and the u as sleep disorder. Let's look at it. We get the same thing. We see here that majority of the males are more healthier and females have more disorders over here. We can see orange and green represent disease. They have a disease. So here it's very less and here it's very high. So the we can conclude that females are mostly suffering from a sleep disorder than males. So yeah, this is the so yeah this is the analysis that we got from the above analysis. So so yeah this is this is the conclusion that we got. So this is the conclusion that we get from the above analysis. That is, 55% of females have sleep disorders, while only 27% of males have sleep disorder. Now let's start looking into body mass index. We're doing the same thing. We're taking all the unique values of body mass index. So the unique values are overweight, normal weight, and obese. Um, there are only less number of people who are obese, and mostly all of them are normal weight, and some are overweight. Okay, let's visualize it for further better understanding. We're using the same count plot from Seaborn. We're giving the data as body mass index. Let's look at it. We can see that people with overweight are the ones who are mostly suffering from a sleep disease, whereas people in the normal weight category are not suffering at all. It is surprising to see that obese people are not suffering, but I think it's because of lesser number of data available for comparison. Now let's look into other parameters. The first one is quality of sleep and stress level. So now we are doing something different. We are not just plotting graphs, we are plotting subplots. Subplots are like two graphs which are plotted simultaneously. So the first subplot which we consider is for quality of sleep, and the second subplot is for stress levels. Let's analyze the data. Here we can see that people with less than 8 points for quality of sleep are suffering from insomnia. And for sleep apnea, there's no proper variation over here. And for stress levels, it's very mixed up. So there's a lot of variation. So I think this is not a good parameter for analyzing. Let's look at this. Yeah, we can see that those with less than 8 points of sleep often have insomnia. Yeah, we just saw that. And except for sleep apnea, which ranges from 4 to 9. And then we're excluding 7 and 8. Okay, stress levels don't have clear dependence. Yeah, as you can see, stress level graph has a lot of variation. So I think this is not a good parameter for analyzing the data. Let's go down. And then now now we are analyzing sleep disorder based on people's age and their physical activity level. For this also, we are plotting subplots. Now let's analyze the plots. When analyzing the age plot, we can see that people from age 40 to 50 have high chances of having insomnia, and people from age 30 to 40 have no disease, and there's a high chance of developing sleep apnea from age of 50 to 60. And taking physical activity level, there's no proper variation of here. And yeah, regarding age, most people from 40 to 50 have insomnia, while those over 50 tend to have sleep apnea. Yes, we just analyzed that. Now let's plot subplots regarding heart rates and daily steps taken by the person. On analyzing heart rate, we can see that People with heart rate of 65 till 75 have no disease, and sleep disorders, people walking from around 6,000 to 8,000 steps are not having any disorder. Then the next thing is we are plotting a histogram for sleep duration. The next thing is we are plotting a histogram for sleep duration. Here we can see that people with less than 7 hours of sleep are suffering from insomnia. So people with less than 7 hours of sleep, there's a chance of developing his insomnia, and people with sleep duration greater than 7 hours have no disease, but there's a variation over here. Let's take blood pressure under consideration. We can see blood pressure as two parameters over here. I think one is for diastolic and one is for systolic. Now let's go down. So let's split those two parameters into different datas. So how are we going to split it? We are going to use the Python split method, which splits um, which splits wherever this separator is present. So when we split it, we get an array of two items. So the first item we get is for these columns, and the second item for these columns. Now let's do the same thing. We are going to plot subplots using the C1 library, and let's analyze it. So there's no proper variation over here. Let's plot scatter plots. Scatter plots are used for comparing several parameters and also find outliers. So here we are taking sleep duration and age as parameters. So we can see here that as sleep duration increases for all the age groups, as sleep duration increases, there is less chance for developing a sleeping disorder. And as sleep duration decreases, we can see that people are suffering from sleeping disorders. The next thing that we are considering is body mass index. We are plotting a histogram. We can see that in our earlier analysis, as we analyzed earlier, we found out that people with overlight, as we analyzed earlier, people with overweight are most likely to develop a sleep disorder, and here we can see the same. People with overweight are and age of 45 are more likely to develop sleeping disorders. The next thing that we're doing is we are plotting a heat map. Heat map is nothing but they are used to find the correlation between several attributes of a data set. So here we're taking all the attributes from age, sleep duration, quality of sleep, physical activity levels, stress levels, until blood pressure. So here we are plotting a heat map, and the analysis from the heat map is age has a clear correlation with quality of sleep, and the stress levels and blood pressure. Sleep duration correlate with quality of sleep, stress level, heart rate, and sleep duration. Physical activity also obviously correlate with daily steps. Yeah, as we analyze this, we can observe those data. So that's all for visualization. Now let's look into all the key points that we have analyzed from all these visualization. We found out that there are three main classes, which are no disorders, sleep apnea, and insomnia. We also discovered that 40% of the entries have sleep disorders. And in those 40%, the majority of the people are nurses. Nurses are the most number of people suffering from disorders. The next thing is females are more likely to develop disorder than males. As you can see, 55% of females have sleeping disorders, while 27% of male have sleep disorders. The next thing is overweight and obesity are reasons of sleep disorder, because we saw that more than 75% of people who have sleep disorders are overweight. And for age, most people from 40 to 50 have insomnia, while over 50 tend to have sleep apnea. This also correlates with sleep duration. And the next thing we got is, yeah, for sleep duration, less than 7 hours is associated with insomnia, while for apnea, it's not clear. Overweight also increases from 45. Now, as visualization is over, now let's start training models. So before training models, we just do the same thing. I just did it for just like understanding those things again. And the next new thing over here is I'm finding like the next new thing that I'm doing here is I'm checking for null values. Like how many null values are there in each attributes. Here I find that there are no null values because in data cleaning I cleared all of those null values, so there's no null values over here. Now here comes the important part. Now we are going to train a model. So as you can see, there are two variables, x and y. X is the independent variable and y is a dependent variable. So in x we are storing a data frame which contains all the attributes other than sleep disorder and person ID. Because we are dropping sleep disorder and person ID from the data which contains all the attribute. And in y data frame we are storing sleep disorder because sleep disorder is our target attribute. Now we are going to train. Now we are going to train the model using train test split, which comes from scikit model, which is like a famous library. Then the next thing is we are going to train the model. For training the model, we have four variables here, as you can see. We have xtrain, xval, ytrain, and yval. Xtrain is nothing but xtrain is nothing but a training set, and xval is a validation set. Similarly, for y train is for the training set and yval is for the validation set. And then, as you can see, we have specified the test size. Test size is given as 0.2 here. So test size is nothing but it specifies that 20% of the data will be used for validation set and the remaining 80% will be used for the training data set. Like this is a very common split ratio which is used in the industry. And the random state 13 which is mentioned over there is used to set a random seed. So it helps to so it ensures that the data is split in the similar manner every time the code is run. So this can be helpful for like reproducibility. Now let's start creating our decision tree model. Decision tree classifier is a computer program that makes decisions by asking a series of yes or no questions about input data and uses those answers to determine a class for the data. Now, like we are importing a lot of functions from sklearn library. The first one is confusion matrix. Confusion matrix is a table which is used for evaluating the performance of a classification model. The next thing we are importing is the confusion matrix display, which is like used for like visualizing the matrix. The next is we are importing dummy classifier, which we'll see in a moment, and then accuracy score and decision tree classifier. We'll be doing decision tree model in this project. The next thing is we are creating a function which will be used when we create the decision tree model. So the function takes two parameters, y true and y predicted. Y true contains the true data set and y predicted contains the predicted data set, which is what we want. The next is we are assigning confusion, creating a confusion matrix and assigning it to a CM variable. Confusion matrix is like nothing but it gives us information about the model's performance in terms of true positive and true negatives, and also false positive and false negatives. And then CM display is for like visualizing the confusion matrix. And finally, we are using accuracy score function from sklearn to to get the accuracy of our data. The next thing we are doing is we are making a dummy classifier. Dummy classifier is nothing but it's like a baseline model. It's a simple model which is like predefined in sklearn. It gives us like a baseline value of accuracy so that when we create other models, we can compare those models with this baseline to see how better our model is. Now let's start training the decision tree classifier. Here we have used decision tree classifier method from sklearn to create an instance of decision tree classifier and store it in dt variable. Now let's look into the parameters. The first one is criterion. The criterion parameter determines like the impurity measure used for decision making. Now so here we have used the Gini index for that. And the next one is max depth. Max depth is a parameter which sets limits to how deep the decision tree can grow. And the next one over here is min sample split. Min sample split is a parameter which specifies the minimum number of samples required to split an internal node. So in our case, our node must have at least three samples to split the node. The next thing is we are taking the instance that we have created and we are training it. So this line is used to train the decision tree classifier model, and we are passing in two parameter which has the training sets. It has the x training data set and y training data set. The next line, we are predicting the we are predicting the values based on our data set, trained data sets. So for prediction, we are passing in the validation data set, and the corresponding result is stored in the y predicted variable. And in the next line, we are calling the eval model function, which we have created over here. So eval model takes in two values, which is the validation set and the prediction set. The eval model function does nothing but it calculates and displays the confusion matrix and the accuracy score. So the confusion matrix, which is displayed over here, we can see it over here, and the accuracy score of our model is around 94%. So when we compare it with the dummy classifier, we can see that it's like a better model. So in this project, we have analyzed the real world data and looked at what activities actually contribute to sleep disorders in a person's life. We found that parameters like age, occupation, body mass index, and several other features contributes to one's health. We have also trained the model up to 90% accuracy. I hope this video has given you an idea on how to proceed with data analysis. So the concept is similar. This concept can be applied to data sets with over like lakhs or millions of rows. But the approach of data visualization or the data cleaning would definitely be different. That's it for today, and let's meet in the next one.